All right, in this one we have an example of what we call a power series. And a power series is when x, a variable, is raised to a power, and that power is these whole number powers that we're seeing when we do series. But because x is a variable, it can take on different values, we can kind of force this to happen, and we can kind of force convergence of the series for certain values of x. So what this is asking me to do is, the same thing as before, plug 0 in for n, plug 1 in for n, and add these together. So I'd have x minus 4 over 4 being raised to all these whole number powers, which is going to give me 1 plus 1 times x minus 4 over 4 plus 1 times x minus 4 over 4 squared, etc., etc. So this is, again, just geometric with a equal to that first term. A is 1. And r is the thing that's repeatedly being multiplied to a, which is x minus 4 over 4. All right, now, again, this will converge to a over 1 minus r if the absolute value of r is equal less than 1. So first of all, a is 1. 1 minus r is 1 minus x minus 4 over 4. All right, we're going to do the same thing that we did in the previous example. We're going to multiply top and bottom by 4 to get rid of the fraction. All right, distributing the minus sign through, I'll have a 4 over 4 minus x plus 4 would be 8 minus x. Now this is what it converges to as long as the absolute value of r, again this is r, x minus 4 over 4 is less than 1. Okay, now what we typically do with that is give a bound for x. So it means solving this absolute value inequality. And remember, when you have a less than absolute value inequality, it means the thing that's in the absolute values is bound between the number itself that's given here and its opposite. And then you just solve this. Multiply both sides by 4. I get a negative 4 is less than x minus 4 is less than positive 4. And then adding 4 to all three parts of this inequality will give me 0 and 8. So this is the region where this infinitely long series converges to this. Right? This infinitely long polynomial is converging to that function. That's obviously not a polynomial as long as we're between 0 and 8 on the x-axis. Now let me show you what that means. So what I have here is I have the function that we're saying that it converges to. I have the first term of our series, and then I have the region on the x-axis where the convergence occurs, or what we call the interval of convergence. So I'm going to turn this on, and you can see that right there in the middle of this is from 0 to 8. So right in the middle would be 4, and you can see at 4 we're evaluating this and we're getting 1. So y equals 1. That crosses this right in the center of this interval of convergence. All right, I'm going to add to that this second term, and now you can see what basically we've created is a tangent line. So the first two terms of a geometric series like this, or a power series, I'm sorry, of a function is the point of tangency and the tangent line, basically, at some point in that interval of convergence. All right, now we're adding the third term, and that's the x minus 4 to the second power, and you can see there's that same point of intersection. Now you can see that instead of it being a tangent line, we have a parabola, and we're bending up on the left side, we're bending up on the right side. So what happens here is it matches the first derivative, the tangent line, but it also matches the second derivative, matches in concavity there. And every time that we add another term, we match another derivative. So the first derivative of the original function, or the function this converges to at this point in question, this is 4,1 point, matches this function. In height, it matches it in the first derivative, the second derivative, now the third derivative. And that will continue no matter how many terms we add. But the point is, the blue graph is hugging the red graph more and more and more in this interval the more terms that we add. So there's the fifth power, seventh power, and so on. So again, what you're seeing is you're seeing less and less of the separation further and further out from that point 4,1, that point of tangency. So you can see what basically has happened. The more terms we add here in this power series, the closer this this is a polynomial, the closer this polynomial hugs this original function.